Welcome to the BelGAS educational series. Our intention is to help educate on a range of information, from basic to technical. Our goal is to add value and support to our distributors, customers, and community. This episode will cover the basics of regulators. Let's get started. What are regulators? Regulators are defined as devices for controlling fluid flow. Exact application needs dictate the configuration styles and settings of regulators, which typically require engineering and design. We will focus on natural gas today, which is just one of the plethora of media that can be controlled by regulators. Others include, but are not limited to, air, water, oil, and exotic gases. What do regulators do? Regulators are used to control pressure and flow. High pressure is used as a moving force to send gas through pipe networks. But the pressure used to move gas is too high for use in things like appliances and burners, so regulators reduce that higher pressure to more manageable levels. Now let's take a look at how regulators work. As higher pressure gas moves into the regulator's body, the rising downstream pressure pushes against the diaphragm, balancing the spring's exerted force. The downstream pressure's force and the spring's force meet at the regulator's set point. Where can you find regulators? There are regulators everywhere. You can find them at the doctor's office, the cafe, and even the grocery store. Regulators are typically found within proximity of meters and other metering and regulation equipment. Pictured are real-life examples of regulators. On the left are regulators at a gate station, and on the right, a regulator in use at a restaurant. Let's discuss the different types of regulators. Regulators can generally be categorized into two different types: pressure reducing and pressure relieving. Pressure reducing regulators create differential or pressure reduction in the pipeline. Pressure relieving regulators reduce the pressure in the pipeline by redirecting the higher pressure out of the pipeline. Both pressure-reducing and pressure-relieving regulators can operate as standalone units, which can be referred to as direct-operated, or be externally controlled by another device, which can be referred to as indirect-operated. The supplemental devices in an indirect-operated regulator can help the regulator more accurately operate within the necessary flow and pressure parameters. Next, let's review some key parts of a regulator and their function. We'll review 9 key regulator components as represented in the cross-section drawing. The bonnet cap is a seal to the spring case of the regulator. It can be used as a tamper-proof seal and is sometimes used as a visual color indication of delivery pressure rating. The adjustment screw is the user interface to manipulate the exerted spring force. Its linear travel compresses the spring and then holds it in place when the desired pressure is achieved. The spring is the force-generating element that balances the downstream pressure on the opposite side of the diaphragm. The orifice is the restricting element that helps fine-tune the size of the regulator in relation to the application conditions. The regulator body is the physical connection point of the regulator to the pipeline. There is typically an inlet, where the high pressure comes in, and an outlet, where the lower pressure goes out. The internal relief spring is effectively a pressure-relieving regulator built within a pressure-reducing regulator. It is a backup safety device in the event of a problem with the regulator's operation. The seat pairs with the orifice to close the regulator. When the seat moves away from the orifice, flow and pressure increase. When the seat moves closer to the orifice, the flow and pressure decrease until full closure or shut off of flow, which is also referred to as lockup. The lever is the link between the diaphragm plate and the seat, which allows modulating downstream pressure to move the seat towards or away from the orifice. The diaphragm is the balancing point between the downstream pressure and spring force. It has a large surface area to create the most efficient balance of these opposing forces. Why are regulators important? Regulators are critical safety devices that are used to create usable pressure conditions in many industries around the world. They are important for a variety of application styles, including industrial, commercial, and residential. Next time you walk into a restaurant, office, or your home, If you have natural gas service, remember, there's a regulator nearby, keeping you safe. This concludes our What Are Regulators episode, a part of the BelGAS educational series. We hope you learned the basics and more about BelGAS regulators. If you liked this video and are interested in more videos like this, like and subscribe to our YouTube channel. If you have any questions or need support, please call or email our engineering and customer service teams, located in Newell, West Virginia. If you need more information, visit belgas.net and make sure you are following us on LinkedIn. Thank you for watching.